Hello class, this is your last lab. This is lab 10. You see if you scroll up here, what you're going to need to do is watch the vodcast. Somehow the vodcast got deleted, so I'm making a new one right now. You need to fill out the worksheet and upload it, and you're also going to write a lab report. And the lab report is going to be over alkenes. So you're going to almost pretend that you did this lab on your own. You know, pretend you actually did the full reaction. And so, for example, the introduction background, talk about, what is an alkene? What's the history behind them? How are you exposed to them? Just the background information of an alkene. And the hypothesis, look at this lab, read over it, over here, the purpose and everything, and see if you can figure out what you hypothesize. What do you think is going to happen in this lab based on what you know, based on your knowledge? For the materials, just the materials should already be listed on here. Let's see, or the procedures. So just list the procedures right here. You could just list those. You can copy and paste those. I don't care. For the analysis, what you're going to do is use the data I'm giving you in this vodcast for this report sheet right here. Okay? So this is going to be what you're going to, so this is your data, and you're going to analyze it. Okay? Also analyze different things I told you in the vodcast. How you know things are happening. And finally, the conclusion, you're going to conclude everything together. What did you learn in this lab? Anything you would change? And then finally, the practical applications. How do alkenes affect you? How, not necessarily the one that we made in lab, but just in general. Where do you see double bonds? Think of like lipids and everything. So how do double bonds affect your diet? How do they just affect your everyday life? So let's get on to the actual lab. If I scroll here, in this lab, if you had the materials and everything for it, you would have done an alcohol dehydration. Okay? So let's think about this. Dehydration, or hydration, means water. So we're going to dehydrate, meaning lose water. This is an E1 reaction. Okay, so let's think about this. Was OH a good leaving group? No. How do you make it into a good leaving group? You need to put a hydrogen on there. How do you put a hydrogen on there? An acid. Because remember, what is the only role of an acid? Is to give up a hydrogen. So what we're going to start with in this is use sulfuric acid, a very strong acid. This will add the hydrogen onto your OH group here. You see here, this is our pretend sulfuric acid. It adds a hydrogen. Now water can leave to form a carbocation. Okay? After the carbocation's formed, the sulfuric acid, which now is one hydrogen less, it wants to reform itself, we'll grab another hydrogen off of here, and then that'll form the double bond. You see here, right here, this is just showing water. Water can take it off. Grab a hydrogen. Hydrogen leaves its electrons to form a double bond. Okay, so let's look at the procedures that happen here. The first thing we're going to do is slowly add sulfuric acid, okay, to our beaker. And then we're going to add 2-pentanol. Okay, so again, pentanol, all meaning alcohol, pent meaning 5 carbons. So we're going to have a 5-carbon alcohol, the alcohol found on carbon 2. Now alcohol is not a good leaving group, so we have to add our sulfuric acid to make it into a good leaving group first. Okay, then what we're going to do is it's going to react, and it's going to react pretty fast, and we're going to do a distillation. Okay, so distillation, there's 2 reasons we do this. First, it's going to heat up the reaction to allow it to occur. So it's going to allow the sulfuric acid and the 2-pentanol to react together. Okay? So during this time, it's reacting together. And then the second thing it does, the main purpose of a distillation usually, is to separate our two products. Okay? So our main product we're going to have is the double bond, the alkene. Alright? So we want to separate that out. Now let's think about this. An alkene probably has a boiling point maybe around 20 degrees Celsius. Okay? A very low degree boiling point. Okay, our other byproducts, maybe we have a little bit of sulfuric acid still left in there. You know, maybe not all of it reacted. You also have some 2-pentanol that maybe didn't react. Okay, so in our beaker that we're distilling, you're going to have first, you know, your product that you're trying to make, your double bond, and your reactants that haven't fully reacted. So you're going to have 2-pentanol and sulfuric acid all mixed in there. And we want to separate these out. We don't want to have this mixture because we only want to form one product. So let me show you a picture of a simple distillation. It looks like this. Okay? What's occurring here? First, this is the thermometer, so you can kind of keep track of the temperature. So if let's say that the alkene boils at 20 degrees Celsius. Okay? Let's say the 2-pentanol boils at 60 degrees Celsius, and the sulfuric acid boils at 90 degrees Celsius. Okay, so we have a 20, 60, and 90. Now if I set the temperature, let's say at 30 degrees Celsius, okay, will the 60 degrees Celsius pentanol boil? No, it's not high enough. Will the sulfuric acid boil? No, because it boils at 90. So those won't boil at all. Okay, they'll remain there. But if the alkene that boils at 20, that will boil. Okay, so what will happen, here's the mixture, here's our product. This is just a heating apparatus, so it's going to heat it, allow it to boil, set it about 30 degrees Celsius. It's going to react, and then we're going to see some boiling. And what's actually boiling is the alkene, because it boils at such a low temperature. Okay, so it's going to start going up here, and when it boils, what does it become? A gas. So we're going to have the gas come up here, and then it's going to travel down this tube right here, and then into this little round bottom flask. Now this round bottom flask, it doesn't really show it very well, but it's in ice. It's in an ice bath. Okay, so let's think about this. I have a gas. It's traveling up here, down through here, and it's trapped over here. Why would it be trapped here? If I all of a sudden, you know, freeze the gas, I put the gas in this cold water, it's going to turn back into a liquid. Okay? Because I'm freezing this. This is, you know, close to 0 degrees Celsius right here, so it's going to become a liquid. So I make my product, it starts boiling off, comes down here, and I trap it in this ice bath. So now I've separated it. So now I have only my alkene over here, everything that boiled off, and over here I have left my sulfuric acid and any leftover pentanol that didn't react. Okay? So distillation is a separation technique, and you can only do it whenever you have differences in boiling points. So, and drastic differences. So if I have one that boils at 20, one that boils at 22, that's too close. You're not going to get very good separation. But if something, let's say, boils at 20 and then something else at 40, I mean, you could easily separate it. You know, set the heat up to 25, and you can leave the one that boils at 40 in the beaker, and the other one will travel over into the round bottom flask. Anyway, so that's the point of the distillation. So it's to heat it the reaction for it to go, and then separate it. So that a distillation usually takes a while. So it usually goes for about 2 hours or so. The other thing you're going to do, if you read through the directions, is you're going to separate it using a separatory funnel. Now let me show you a separatory funnel. It's going to look something like this. Okay, so you're going to put your final product into this little tube thing here. This is a separatory funnel. Okay, and then you're going to wash it out with a little bit of water. And the reason you do that is just because there's always impurities in there. As much as distillation separates a lot of them out, but there's always something in there. Okay? And what happens is, remember, like dissolves like. So you're going to have your polar versus your nonpolar. So anything that's polar that's left in your product will be taken out, will want to go to the water layer. Remember, water is very polar. Okay? Think of like oil and water. They form two different layers, okay? So if I put some water in there, I shake it up, anything that's polar that was left in your product is going to go up to the water because it's attracted to the water. It's almost like a magnet. So it's just a way to separate, everything further out. And let me show you what that would look like. It would look something like this. Do you see that they're clear? And this is how it would pretty much look. But they're both clear, but you see they form two layers. The bottom layer is usually your quote-unquote water layer, okay, your polar layer, with any of your polar impurities. Okay? The reason it's at the bottom is because of density. It's usually more dense, and so it's going to go to the bottom. The top layer is a little less dense. This is your quote-unquote organic layer. So this is usually like the product you're trying to form. So here's my product up here, and here's my water layer. How do I know it's my water layer? Well, let's say you don't know. Okay, they look similar. They both kind of look like water. Well, just put a little bit more water in there. Whichever layer grows, that's your water layer. Okay, as simple as that. Now, if I come back over here, you would form your two layers, and you see you could put a flask down at the bottom and literally just drip out your water layer. Just separate them, by looking at them. So I can separate both of those out in two different flasks. And the last thing you're going to do is use a drying agent. Okay? This is sodium sulfate. And what this does is any leftover water, because when you separate these, we're human. Okay? And you could separate the water out, and then you'll have your organic layer, and you're going to separate that out. But there's still probably a little bit of water that got stuck in there. Okay? So what a drying agent does, it's a salt. Okay? It's highly attracted to water, and it's basically going to just take all your water out. Okay? It's going to absorb it and leave you only with your organic layer, which you can weigh. Now the mass of the crude product, when you do this, will come out to about 1.96 grams. Okay? And that's the crude product with all the impurities. Now when we did this, we then purified it. So the mass of the crude product was right after the distillation. What did we have left? It's 1.96. Then we used the separatory funnel, and we separated the two layers. Then we used the drying agent to separate it even more. And the final product we got weighed 1.5 grams. So you see we lost some mass, and the reason is because we lost impurities. Okay? So think about where the organic layer be found. Think about what I said earlier and how you can tell. So that should help you with this lab here. And see if you can figure this out. So this is a pretty typical lab we would do in organic chemistry. This is a synthesis. So we're starting with an alcohol and we're making an alkene. Anytime you make something, that is a synthesis. So hopefully this helps you understand this lab, and good luck.